All right, so I'm going to get started. So this is Jets, a Ruby Serverless Framework. I'm going to talk about a tool I created here. And the first traditional slide, of course, is the traditional introductory slide, who I am, what I do. My name is Tung Nguyen. I run right now a consultancy company called Bolt Ops. Is the kind of icon up there with the lightning bolt on the left-hand corner there. It's focused on kind of AWS and software and infrastructure. I've had the actually luck to been created all these kind of tools, these icons you see up there, and it really runs the gamut. I have tools in Elastic Beanstalk. There's a CloudFormation framework up there. There's also an ECS deployment tool. For my work in the space, it was quite an honor to be recognized by AWS themselves to be recognized as container hero. It's a big honor for me because there's only 5 of us in the world in that category. But today, we're going to talk about Jets, the Ruby Serverless Framework. I think one thing I want to point out is, because I actually do a lot of work in container space too, I feel like I have appreciation of both on when you should use containers versus when you should use serverless technology. So we'll talk about that a little bit now. Okay, so the reason why I think we're here is because in November 2018, AWS released Ruby support officially as a runtime for Lambda. This was a big deal because prior to that, Ruby wasn't actually an official runtime, so you'd actually like bolt on support yourself. So it wasn't as accepted. But this put Ruby as a first-class citizen in the serverless world. For me, it was like a Christmas present. This is actually a picture I took at re:Invent front and center stage, and I literally screamed when they kind of made the announcement. I was like, yes, I guess for the Ruby community, that's kind of like when a new version of Ruby gets released there in December. But for me, this is like very big news. And I thought one good way to introduce actually the serverless world to maybe this group is to talk about some actually essentials of AWS and the compute offerings that exist today. So on the left side is EC2. So that's just a regular virtual machine. You spin up, it takes about 2 or 3 minutes to click a couple buttons or call an API to create a machine. Then you can install anything you want on it. You kind of manage that server, you patch yourself and all that. So that's a little more managed. As you move from left to kind of right there, it becomes less and less managed by yourself. Somebody else manages it. ECS stands for Elastic Container Services. What Elastic Container Services essentially is a service from AWS that allows you to run Docker containers very easily on EC2 instances. You don't really have to do much. And then the far right, that's AWS Lambda. So that's what we're going to talk about. So what is AWS Lambda? I put quotes around this and a happy face because people are calling it serverless, and I guess this term just picked up. It's a very hypey term. It got popular, but I think this is kind of like a bad name because in order to run serverless technology, you need servers. So it's an oxymoron. So here's another definition. It's functions as a service. That's one way you can think about serverless technology. And another way to explain it, a third time, is essentially as a way to run code without managing servers. You give AWS Lambda your code, and then they figure out how to run it. Okay? There are some benefits with AWS Lambda. Maintenance. So you don't have to patch the servers yourself. You don't have to do system upgrades. You don't have to worry about security updates. A team of AWS engineers will handle that for you. Maybe they have hundreds, maybe they have thousands of engineers working at full time. All you do is focus on your code. It continuously scales on demand, depending on how much requests you send it. So when EC2 came out with autoscaling, I thought that was an amazing feat of engineering. I thought that was quite amazing. All you do is configure some autoscaling policies, some alarms, some rules, and then your systems will kind of horizontally scale up and down automatically. Now, with serverless technology, it just happens. You don't even configure anything, it just continuously scales. So one less kind of mental thing you have to take up, deal with as an application developer. And then the last kind of benefit here that I'm covering here is pay per request. So with AWS Lambda, it's a really interesting pricing model. You only pay for the requests you send. So if you fit within the free tier, which is about 1 million requests a month, you can essentially run your code for free. Right? So I think that's a pretty interesting model. Of course, there's a lot of serverless hype. A lot of benefits, but let's address some of the hype. Okay? Like the term itself, serverless, that's hype. Right? So let's talk about some of the considerations or limitations of maybe why serverless might not make sense sometimes. Okay, so AWS Lambda, there's some considerations. The first one I'm going to cover is RAM. With a Lambda function, essentially what happens is a container spins up, and you can allocate 120 megabytes of RAM to it, or up to 3 gigabytes of RAM. So with the typical Ruby process, let's say a Puma server, what you do is you configure processes and the number of threads, right? And a typical Rails application might eat about 500 megs. then you could multiply that by the number of threads, and that's how much RAM you need for the system. With kind of AWS Lambda technology, you're not actually configuring threads. The entire process itself scales. So what you're actually worried about is whether or not your Ruby process itself is going to take more, consume more than 3 gigabytes of RAM. And if you have a Ruby process consuming more than 3 gigabytes of RAM, you probably have other problems. So I don't think that's actually a limitation here. Okay, now CPU. So your CPU, the CPU that you get is actually proportional to the RAM you actually allocate to the function. So the more RAM you allocate, the stronger CPU you get. And the magic number around rumors are 1.5 gigs. Then you get multiple core. You get 2 cores. Now, most applications are usually actually memory bottleneck in Ruby. So I don't really see CPU as kind of a bottleneck. I don't think it is a choke point. Unless you're doing maybe Bitcoin mining, then maybe you shouldn't be using it. Or HPC, high performance computing, then maybe it's not the right fit. But most of the time, you're not going to be bottleneck the CPU, I find, or maybe you have an infinite loop in your code. So that's going to probably cause the CPU bottleneck. So that's just bugs. Okay, another consideration is the network pipe, right? How fast is the network, or the network cards here? And you're on AWS network speeds. So if there's a problem with their network speed, other customers are going to complain. So I don't think that's actually really an issue either. Okay, now this might be an issue depending on what application you're running. So 15 minutes is basically the longest time your function can run before it times out. This was increased about 2 years ago from 5 minutes to 15 minutes. Now, if you're basically handling web applications and the user's waiting for 15 minutes, they're long gone already, right? So this is not really a concern either unless you're running a really long process, okay? Now, this one I think is actually a valid concern, particularly for Ruby projects. Expanded on the file system, your application can take 250 megabytes of space on the hard drive. RAMs, they get, gems with the dependencies, that is included in this figure. So that means if your dependencies and all that, they add to 50 megs or 100 megs, you only have 150 megs left for your application code. So this could be a constraint, and this is something that you guys have to watch out for. I think, it seems like AWS, I'm guessing my bet is they're going to eventually kind of increase this also and then kind of remove another wall, okay? Okay, and I want to address this, the cold start. This is what a lot of people talk about when they talk about AWS Lambda. And so that's supposed to represent an engine that's code and it's covered in snow. And so the cold start issue is this. When the request comes to AWS Lambda, essentially a container spins up. And the first time it spins up, the very first time, there's a kind of overhead associated with it. There's a penalty. Now, if you're being really, really cheap with your functions and only allocating 128 megs of RAM, the penalty is about 1 to 2 seconds, so that's considerable. But if you're not, like, if you're using them for real world use cases, maybe a megabyte of RAM, and I've seen it about like 300 milliseconds. And so I think this is interesting because people make a big deal about this, but it really reminds me of Rails Russian doll catching. So the Rails Russian doll catching, basically you have a cache, a fragment cache, and you have a cache key with an updated timestamp that's associated with that cache key. When you update that post, that timestamp changes and you get a fresh cache. Well, guess what? That first request is going to be code. And then you're going to hit SQL queries, you're going to hit whatever, and then their application might be, like, I don't know, 500 milliseconds, right? But that's what people are doing. So unless you're basically building NASA spaceships, I think you're going to be okay, right? And the function, what happens is Lambda, they actually reuse the function for a period, like when I was testing about 4 or 5 hours, but they don't have exact specs on this, but it runs actually for a long time. So the workaround is, that's not an engine on fire. That's supposed to represent pre-warming. So I can do better. Here is a better diagram. So this is kind of the pattern people are using to keep your functions pre-warm. So you basically have one Lambda function, basically calling out to all your other Lambda functions and setting basically a dummy payload that keeps those functions warm, and then basically removes the cold start penalty. So Jets does this on deployment, and also does this as a part of some configurations by, so supported with just some settings. Okay, so if pre-warming is still a concern, you could actually get around with this. Okay, so I thought, we cover AWS Lambda, but there's actually more to serverless than just functions. There's something called API Gateway, okay? So with API Gateway, you can think about it as a front door. Users then request to API Gateway, and then API Gateway routes that request to different Lambda functions, okay? Another diagram to explain this is you could build RESTful API with the API Gateway. So you can see right there, users basically come in with requests, they go to a URL with the HTTP verb. It gets kind of sent to downstream to a Lambda function. The Lambda function returns back. So you could think of API Gateway as routes as a service. Okay, there's even more to serverless. There's something called CloudWatch. So maybe those who might be familiar with CloudWatch are thinking about CloudWatch logs, but there's many features within the CloudWatch offering, and the feature I'm talking about is scheduled events. So within CloudWatch, there's a feature called scheduled events where it allows you to periodically call something repeatedly. Essentially, it's a clock. It's a scheduler. But again, it's something you don't manage. So you can actually hook up a scheduled events and repeatedly call Lambda function. So let's review the essentials. Serverless components. Lambda is functions as a service. API gateway, routes as a service. CloudWatch logs, schedule events, or a scheduler as a service. Okay, with all those components, we could build a web API architecture, all completely on serverless. So users come in, they hit the API gateway RESTful endpoints. Those get sent off to Lambda functions. Those Lambda functions, again, are serverless functions. Now, they could call a backend store like DynamoDB, which is a document-based serverless database, or RDS Aurora serverless, which is also, it scales basically on demand also for you and it increases number of connections on demand. It's another serverless offering. And then at the bottom there, you have CloudWatch events, which is a scheduler that is calling a hard job. Okay? So let's actually finally see some serverless code. And I thought a good way to kind of explain this and introduce this is actually just go through the web console. So AWS calls this the console, is essentially the web browser. You can use the web browser to create functions. So let's walk through one. You just have to find the create function button. Then you assign it a name. Then you assign it the Ruby runtime there. And you click create function. That takes you to the show or /edit view. And basically is an IDE editor built in. And I wanted to point out in this, there's the Lambda function, the handler part. The first part before the period, Lambda function, is the file name. So you can see how it goes to lambda function.rb. And the part on the right, Lambda handler, that's actually the method that gets invoked. All right? And then you see the signature of what actually a Lambda function looks like. There's a keyword argument, event and context, and then this method is returning a hash structure, status, code, and body. And in the console, you can actually edit this code live. Okay? And you can actually test it live too by hitting the test button. Once you hit the test button, you can see it live, results spinning back at you. Pretty easy to use. You can do it all in the browser. All right? Now, next up is API gateway. So how are we going to create an API gateway here? In the browser again. This is an API gateway console. You basically specify that you want a RESTful API. You specify a new API, and you specify an API name. You click create API. It takes you to this view, which allows you to create basically the resource routes and then the HTTP verb, like get in this case. And so you can see I'm creating a GET request on the home page, and I'm associating with the Lambda function number 2. Then number 3, you type out the Lambda function and it auto-completes, and then you click save. Then it takes you to another page where it actually shows you a really nice visualization. The request comes in, it hits the Lambda function, and goes back out to the user via API gateway. Okay, and then finally, CloudWatch logs. How do you create a schedule rule? There's basically the rules tab there. You could click schedule, and then you could specify your target as Lambda function, and then you click configure details. There's another confirmation box to enable the function, and then you create rule right there, and then you get the show page where it shows you this is going to be scheduled for a rate of 5 minutes, and it's called that Lambda function repeatedly over and over and over. Okay, so congratulations. We just had a crash course on serverless, right? Lambda, API gateway, CloudWatch logs. Okay, so a lot of people, when they're working with serverless, they're not going to literally go create all their functions on the console. That's because insane, that's madness, right? So instead, they do this madness. This is how actually people code right now in the serverless world. This is YAML. So this is a Lambda function written in YAML. It's just this is a structure most people use. And this is kind of how I feel about that. I feel like its configuration is not code. So that's why I wrote Jets. That's one of the reasons. Okay, so let's actually see some Jets code now, right? We cover some baseline fundamentals. Let's look at Jets code. First is a Jets simple function. So it just looks like the Lambda handler that we created in the console earlier. But there's not a lot of value here, to be honest. But you can do it in Jets. This gets a little more interesting. This is a Jets controller. It might look familiar to some of you guys, right? There is an application controller, post controller inherits from that. There is 2 methods here, or 2 actions. Those are public methods. I'm pointing out public methods because although that might look like a typical Rails controller, those methods actually get translated to, guess what? Lambda functions by Jets. So Lambda basically evaluates your code and translates any public method in that class to public functions, and it provides some helper methods like render. It can render JSON, it can render XML, it can render HTML. There's also params helper that kind of parses basically the event payload. You can access the raw event payload too, and put statements goes to centralized logging, CloudWatch logs. Okay? Next is the routes file. So that looks probably like a typical routes file that you guys might be familiar with. But guess what that route file gets translated to? API Gateway Resources. Right? It's just a DSL that wraps it around and eventually provisions the API Gateway Resources. So you see the get method, the HTTP verb, on the post URL there is going to get routed to the post controller with the index action. Okay. All right, just jobs. So this sometimes, you don't want work to be blocking the web request if it's like a long-running process, so you run it asynchronously off the web request response cycle. So the job concept is here, and you can see there's kind of two keywords there. There's a rate keyword and there's a cron keyword, so there's different ways to kind of create the schedule event. And guess what those things do? They create CloudWatch rules. All right? Jets kind of parse just evaluates your code and then basically creates the resources for you and associates with the Lambda function. Okay, so let's review the components once again. Ruby methods, public methods, and classes gets translated to Lambda functions. Routes, they get translated to API Gateway RESTful resources. Jobs, those rate and cron expression gets translated CloudWatch schedule event rules. All of this is managed for you. Okay, Jet's project structure, it looks pretty traditional MVC. There's an app folder, and in there's controllers, there's helpers. The JavaScript folder has assets like I'm using Webpacker right now. The jobs folder, the models for Active Record and DynamoDB models, both are supported in the same application. Views, if you have an HTML app, configurations for initializers and environmental variable overrides, and other settings. DB for migrations, public folders for public files, and spec for our spec tests. Okay, and I just wanted to kind of review again why. So the YAML there is not so bad. It's only 15 lines of code, right? But I mean, Ruby makes me happy. So I prefer to write the 6 lines of code. And for applications that kind of grow in size, eventually the 15 lines of code, you're going to have more lines of code there, and the Ruby kind of keeps it kind of compressed. I think it's really interesting because it reminds me of Java, I guess, in the 1990s. A lot of frameworks came out, struts, I guess, Spring, and a lot of kind of your logic move out of like Java, which is like, a programming language, to XML configuration land, where your job became this kind of adventure of trying to figure out the exact XML configuration that you needed to change, that you knew was going to change some Java code somewhere downstream that was going to fix your bug, right? So instead, if you should keep coding code. Okay, so demo time. I like to live a little dangerous, so I'm going to do a live demo with Wi-Fi here. Okay, so for the live demo, this is going to be pretty funny. I'm going to literally go to the documentation and copy commands. Okay, so going here, this is my terminal, Jet's new demo. So what Jet's new demo does is it creates you a starter skeleton project with all the files you need. See, it's creating the app folders, creating the controllers, and then it does a bundle install immediately. And then after a bundle install, this is actually is doing a Webpacker install. So because there's kind of 3 modes Jet's new. There's HTML mode, there's API mode, and there's a job mode that's extremely lightweight. So right now, what it's doing right now is a Webpacker install is doing Yarn because Webpacker uses some node modules. So it's kind of building that out. While that's building out here, I'm going to start exploring because the files have already kind of been generated. So I can show you what was kind of created with that command. We go controllers, there's application controller right there. And while I was kind of exploring, you can see what it did was it finished kind of the new command, and then it gave you some instructions. So I'm just going to follow the instructions, cd demo, and then I'm going to go ahead and generate a scaffold. I'm just going to generate a simple one. So Jet's generate scaffold post title string. That's going to generate a scaffold. So you can see the post controller that we just generated right here. And that here is from application controller, and you can see kind of the 7 RESTful method names that are going to be translated to Lambda functions. Your typical helpers here. So there's helpers. Let's look at job. There's this job there, models. The post model that was generated with the scaffold. And here's from application record. Application record is active record base. Okay, there's views here. So there's some layouts. Right here, there's the layout. There's more views here with the form, with the index and edit. Let's go back to controllers, and let's look at, I think, routes. Let's look at routes. So routes, let's drag this over here and kind of organize things. So here's the controller, and here's the routes, and this is like, this resources keyword just expands to 7 routes. Another way you could actually look at this is, I guess I'll do this, cd demo jets routes. So it's going to spit out all the kind of the routes that are associated with this routes file. Let's move this here so you guys can see it. Okay, and now I'm going to do a couple. Oh, you know what I should do? I should actually start the deploy because that takes about 2 minutes or so. UMV development. So I just have to copy a .umv file because that has the database connection settings. And I'm going to start just deploy now. Okay, so that's going to essentially take this code and deploy to Lambda and everything. And also, what I'm going to do while we're waiting for that is I'm going to go kind of show you local server. So Jet server will spin up a local server. I'm actually binding this because I'm running this on something called Cloud9. So I actually hooked up this DNS endpoint to that local server essentially. So this is local right now on the machine. This is the local server I spun up. So there is the CRUD application. Let's go back here, and you can see the request coming in right here. Let's close this off right here, and basically processing. Oh, those are assets right there. But let's go click around. We're testing locally right now. Test 4, submit. There's CRUD, back. You could go edit for fun. Okay, so that's done there. And this still is deploying, so let's explore a little more. So here's your public folder, here's your specs folder. It gives you some starter kind of structure, but specs is something that I want to add a little bit more to. So the deploy should be complete in about a minute or so. Let's see what else I can show you guys. I didn't create a job in this case for the sake of time. Application, I guess I could look at the JavaScript web package stuff right there. Some packs in here, there's a theme. So I think it's kind of deploying. So once it's done deploying, what it's going to do is it's going to spit out an API gateway endpoint URL. And that API gateway endpoint URL is basically the URL that we're going to hit for all the components on serverless. So let's see this API right here, or this URL. I'm going to go ahead and click on it now because it's finished deploying. So what I just tested locally, now this is on AWS Lambda, and this is on API Gateway. And we have a post kind of scaffold. So we go in here, we can edit, kind of some stuff here, submit. It's just basic CRUD. There it goes. Get back. Let's do one more new post. Post 4, submit. So that's just all running on AWS Lambda and API Gateway there. So let's go back to the slide deck. So that's the demo right there. And let's review what we just created. So we created API Gateway, all those RESTful endpoints. We created all those Lambda functions. The database was pre-created. I skipped kind of CloudWatch logs just for the sake of time for demo. But we did that in literally about 4 commands, essentially. Okay, AWS Lambda, it can also be thought of as glue code. So it's functions as a service, but you can also think about it as glue as a service. A lot of people use serverless technology to glue components kind of together. So what type of glue can you glue together? Essentially everything. So this is all the components actually currently supported by Jest natively. You can hook up an SQS queue. I'm not going to go through all of them, but you can hook up an SQS queue and essentially send messages to that queue and have Lambda functions figure, and you essentially have an auto-scaling worker tier. You can hook it up to S3 events, and you can upload basically a file in S3 or a picture and have it kind of automatically kind of resize. You can hook up a third party too. And we talked about CloudWatch event rules and CloudWatch schedule events, and you can even hook up IoT, which I'll cover in a little more detail soon. Okay, so the first kind of glue I want to cover as an example is event-driven kind of security and auto remediation. So what this is CloudWatch. We have a CloudWatch event rule that's being listened to. And what's going to happen is whenever the certain events kind of get registered, is fire off that Lambda function. So the use case for this is this. Sometimes companies might have a policy for security saying, I don't want port 22 open to the world. And then you give your developers access to AWS, and guess what they do? They open up port 22 to the world. So what you can actually do is you actually have Lambda actually resolve this for you automatically. So Lambda is going to listen to events on CloudWatch events here. And if it sees somebody opening up port 22 to the world, it will automatically close that port back up, and it also send you maybe a notification telling you who did it. Then you could maybe talk to them. It's like, oh, our policy is like, and not that lax here or whatever. Okay, so what does that code look like? It looks like this. You can see the pattern. It has the rule event on top of the Lambda function that gets created. And what does it generate? It generates this YAML code that gets shipped. The next one is IoT. So I had a lot of fun putting this slide together. Apparently, you can send pretty much anything to the internet now, like any data you want. Up there's an Alexa, there's a smart home, there's a leaky faucet, there's a tea kettle. You can send your tea kettle data to the internet for some reason. And anyway, you could kind of hook it up to a Lambda function. And so you can actually have Lambda functions and customize your logic based on how hot your tea kettle is, maybe. What does that code look like? It looks like this. This is plain Ruby code with IoT event there right above the method name. And guess what it generates? It generates that YAML and then gets shipped to Lambda. OK, so this is maybe not as much glue, but I think it's a very good use case. Cron jobs, serverless cron jobs. So a lot of people don't back up the Route 53 records. And when you're changing Route 53 records and you forget what value you had, sometimes it's kind of painful. So this is something I like to do. I like to back up my Route 53 records. And you could actually, in the past, what you have to do is actually have a pet cron job somewhere or a pet box somewhere. And you have to manage that server. And then you could, or maybe you're lucky you have Jenkins up. Then you could run your job in Jenkins, right? But what I'm saying is you don't need that, right? You could have this all in serverless. And all you have to do is manage the code. So you could create a CloudWatch event. It calls backup job Route 53. And then it's going to call Amazon's Route 53 API to pull down all the records and maybe create a JSON file and then save it to S3. What does that code look like? It's very similar again. There's the Route 53 records method there. There's the rate expression, and it generates YAML again. And then basically, this is, again, all you do is worry about the code. You don't worry about anything else. OK, I wanted to cover this really briefly, the Jet's core resource model. So that one word over there, rate, 10 hours, actually expands out to resource, that resource method. In Jets, all paths lead to resource. Resource is key. Once you understand that, you can actually extend Jets yourself. Everything actually always calls that. That's what actually creates the resources internally. OK, so some Jets features, prewarming, which I mentioned briefly earlier. So that's just a couple of settings that you configure in your application. Local server for local testing, that's pretty useful before you deploy to test locally, in my opinion. Jets call, there's another way to test either the remote Lambda function or locally, just a CLI command. REPL console, so that's just an IRB console that loads the entire environment in, and then you kind of mess around things and kind of explore your application like that. Database support, there is RDS, right, support via Active Record. There's also DynamoDB support via different gems there. Function properties, I didn't talk about this much, but you can configure your memory settings, your timeout settings, your environmental variables, properties that belong to and are associated with the functions themselves via DSL. IMA policies, this is kind of how you control permissions and access to AWS resources within your account, and you control that too through via IMA policies. And extensions, which I kind of covered there briefly at the end. OK, so here are some Jets examples. There's a repo with a decent amount of examples all working. And there's the site and the documentation site and everything. And I wanted to kind of end with this, the future with a question mark. So AWS has been around for maybe 13 years. They kind of started this cloud infrastructure space, or at least made it bigger. And before, what we had to do was go down to Best Buy and buy a server and drive to the colo and install it and manage that server. That's how you kind of just manage that. That's how things happen. And then the cloud came out, and everyone's like, that's great, but I still need my data center. That's what everybody said. Fast forward 13 years later, most people, unless they have, data centers still exist and you have reasons for them, definitely. But most people usually opt for the EC2 instance instead because there's just less management overhead, right? So now that AWS Lambda is out, right, most people go, oh, AWS Lambda, that's great, but I still need my EC2 instance, right? So I'm thinking as kind of the features are added to these serverless technologies, I think it's just going to be most people are going to kind of go opt in on serverless technology first because the benefits, less management overheads and whatnot. OK, so that is it. The link to the slide is up there. I'm going to be, I guess I have a good 10 minutes for questions and answer Q&A here, and I'll also be around. I'm happy to kind of answer any questions about the tool and anything else. So any kind of questions, guys? or everyone? Yes, and maybe you have a mic or something? Yes, don't have to repeat the question.
Actually, I think I could occupy just like 10 or 20 minutes and keep asking
20
questions.
minutes of questions.
But I tried to focus maybe on more interesting problems for me. And I'm using Serverless Framework. Probably you're familiar with.
Yes.
And I don't like it because it's JavaScript. But I like it because basically I can copy-paste pieces of YAML configuration directly from the cloud formation, and it just works.
Yes.
So of course it's not perfect. It has some like drawbacks. For example, when I was doing authorization stuff, I couldn't just add one line code. I had to fall back to the bigger YAML configurations. But usually if something don't work, you end up like with a little bit bigger YAML configuration, but it works.
Absolutely.
And what I'm afraid, like I really like what you do, but this kind of extra layer that you need to kind of like keep in your head when you transfer from kind of like your Ruby model to the configuration. And do you consider like different formats to be able to create these resources more like YAML-ish way as well? It could be just extension or...
that's the first time somebody's asked me to say I prefer not Ruby, but I prefer the write YML. But I see the point you're making because the resources out there are all, the examples are all YML. Mm-hmm. I probably would not do that. I will probably maybe focus on because there's only so much time in the day, probably maybe focus on converter, YML converter to Ruby code converter. That might be a little more interesting to me. Just because then you're kind of within the programming land instead of staying YML. Converters aren't perfect, obviously, but that's maybe how I would kind of approach that.
I would be careful with this. I do a lot of front-end as well, and for example, in JavaScript front-end world, it's like a lot of problems like you got CoffeeScript and you need to convert it to JavaScript. It's super easy, you can just copy-paste, but it's extra overhead. Each time you think about it, you need to switch context from a really similar thing to the really similar thing, but different, right? And like you make it look like Rails, kind of, I got impression, but a project that basically done the same thing in the front-end world, it was Ember.js.
Yes.
And it was great guy with huge brain, and he designed it perfectly. Mm-hmm. But until you understand the design behind the Ember, you cannot use it kind of like efficiently.
Yes.
And in my team, I got problems sometimes with my coworkers, like I want to do Ember everywhere, but they always afraid and maybe React this time, this kind of problems. So do you afraid that it maybe end up the same thing?
Maybe, I don't know. A lot of this stuff is just kind of like you do it and then you learn it and then you kind of like use that feedback to kind of adjust the framework. I do know, I didn't mention this, but there's something called polymorphic support within Jets where you can essentially call out to different runtimes like Python and Node. So I actually have to use that because there's a lot, like you said, examples out there in other languages. And so in that case, what I'm doing is I'm using Jets as a glue framework. I'm just gluing these languages together. However, I don't have actually like a component where it translates or you can write raw YML, right? And so I'm hesitant around that. That's just where I stand with that now. And I don't like to be absolutist, so I might change my mind, I don't know. Yeah.
Maybe I'm just biased because in my company we did at the moment 3 projects using serverless, and always we end up like really tiny part is actually the routes and API part, but huge part is actually resources, S3, CloudFront, and we do have DynamoDB as well, and maybe like helping people, this is a completely different topic, like DynamoDB is completely different than other databases, so maybe guiding people a little
absolutely.
bit.
So the concept of shared resources, right? Yeah, so you could, in the Serverless JS framework, you basically create these shared resources YML. Jets actually has that same concept, it's just Ruby, but it's a similar thing, so you can create all the things we're talking about. Any AWS resource essentially you create, and it does it via nested CloudFormation stack and passes the parameters through. Jets kind of manages all that. There is a company that just basically like, it's converting all 10 of their serverless applications to Jets. What they're finding is the code size usually gets reduced by a 2 to 3x factor.
Okay.
Thank you.
Thank you very much, because I asked many questions. Probably
Thank
some
you,
other
thank
people
you.
got.
Okay, another question back there. Maybe pass the mic. Thank you. And we got about 5 minutes.
Hello. First of all, I thank you for creating this. Thank you for creating Jazz framework.
Thank you.
I believe future of Ruby is serverless like Lambda. I have been watched Jazz framework, and I try to develop my application by Jazz. But my first thing about Jazz is just something like minor version of Ruby on Rails. It supports like something like active support, and it can generate a model or control by generate commander. But I think it's not complete yet. So my question is, what is the goal of Jet? Jet will be a Rails magic or something like a Hanabi?
I don't think it's going to be like Hanami. Though I want to play with Hanami a little more. I think they have some interesting ideas. I built Jets because I work a lot in the infrastructure space. It's kind of what I do. I also like to use Ruby a lot, and I also like Rails. So I wanted to build something like that actually fit that model. Now, it's not going to be exactly like Rails, but it's kind of close enough because the way Rails operates, it usually it makes some assumptions that's not on AWS Lambda. And the configurations are just different. Like I didn't show you the application configurations, development versus production, but you're actually configuring memory size changes and all that, like timeouts and all that. So I mean, the goal is just to make a framework that actually serves Ruby in the serverless world a little bit more. Right now, I think serverless is kind of being really, I guess JavaScript is mainly the one that's being used in serverless right now. But I would like, maybe it's like a selfish goal. It's just like, I like Ruby, so yeah, this is how I get to use Ruby, right? And for what it's worth, the reason I was so happy with the release of the runtime, thanks to Alex Wood here, is because before then, I had to shove the Ruby interpreter into the runtime, right? And that was an exercise in its own. But now that's officially supported, I think hopefully it's going to spread it a little more. And then that just opens up a world of opportunities, I think, for Ruby developers. Because like I said, I think eventually people are going to be like, they're going to start with like maybe a service first mindset versus a server first mindset. And there's nothing wrong with servers. I love servers. I love Docker. I love ECS. I love all those offerings too.
Okay, thank you.
You're welcome. Thanks. No, right behind you. Okay. Oh, go ahead. Question back. He's standing.
So I was wondering, since due to the pricing model of Lambda, how much overhead is there to Jets in terms of if you just wrote everything, just raw Lambdas versus using Jets to build it up? Are there additional costs associated with that? And I'm also curious what you actually do to generate the code to, generate each of the separate Lambdas from the single application file.
Sure. So the first question was, what overhead does Jets introduce? Probably like it does introduce overhead. I mean, I do this as a labor of love on my free time, right? So there's still overhead there. There's a lot of performance optimizations that I make. I do some bad things, but I mean, it works. And for the most part, usually the bottleneck I find is I/O. That's why I really like that Fiber Talk a lot. I used to operate a pretty high-scale traffic site, and the bottlenecks are usually application code and I/O bound. It's usually not the Ruby code itself. So after like the first request or so, and it's kind of warmed up, I say a Jet's response time will range between 50 milliseconds to 100 milliseconds. So there's not that much overhead there, but there is, and you can probably optimize it. But if you look at our picture, what are you optimizing for, right? It doesn't really matter. And the scaling model of Lambda itself is the entire process. So right, so you're kind of is a different world in that case. And your second question was?
About the actual code generation that you do, how do you do that?
Sure, so I just delegate off to Rails. It reuses Rails generators. I just reuse, again, free time here. So Rails basically does everything, which is actually really interesting because as something for fun, I actually added a carrier wave support, and that got merged into the upstream of carrier wave. And carrier wave uses Rails generators. So Jets has carrier wave generators because the same generators work. which is really interesting. So essentially gems that use scaffolding or like generators, you kind of get for free.
It was really fantastic stuff. Thank you.
Thank you so much. Question in the red shirt?
Wanted to ask, what stage do you think the project is at? I mean, this is coming here is the first time I've heard of Jets. Are there many people using it? Is it alpha, beta? What?
Not as many people are using it as I would like, to be honest. But there are some companies. I've been meaning to put together like a quotes and stuff like that. Like people, email me and message me. I would say they're kind of smaller right now, to be honest. The stage is probably like still kind of beginning. I would say that Jets itself is pretty young. I've been working on it for about a year and a half on and off. The first commit was October 2017. Remember, I built this before Ruby support was added. Just on my free time. But I would say the libraries that it's built on is actually very stable. I'm using AWS SDK, right? I'm using basically AWS to scale. So all the components that is built on top of is stable. The code itself, I think with software, it's very hard to write software with no bugs. So that just takes some time to harden over time. So I think as more usage kind of comes out, it's going to be more and more hardened. That's to answer your question. I think it's still a pretty small project. The funny thing about the statistics is the biggest usage in the US, second biggest usage is Japan.
Thank you.
Yeah, you're welcome. Any other further questions? Okay, great. I'll be around. Thanks.